are responsible for adding and subtracting polynomials, you will oftentimes see them written like this, where we have parentheses grouping the individual polynomials and separating them with a plus sign or a subtraction sign. In those instances, we're not allowed to just dissolve the parentheses. While for addition it ends up working like that you can almost imagine that the parentheses aren't there, the better way to think about it is to continually remind yourself that those parentheses actually mean that we just want one iterance of each of those polynomials. So the thought is, well, I could use the distributive property then to technically eliminate the parentheses and have a string of terms that can be combined. It will not matter for 3 of these polynomials, but it will matter very much that that one is there for one of them. So let's begin with the addition. This one on the outside of the first polynomial is multiplied by all of the terms that are inside, leaving us with the exact same polynomial. And then the same thing happens in the second half. I know it seems strange to just erase the parentheses, but that's really critical to our work in subtraction, so it's a good habit to get into now. Once the parentheses are dissolved, you can start combining those terms that have the same variable part. So we start looking for terms, for example, that have x squared. I have another one over here. 4x squared plus negative 5x squared is going to leave me with negative x squared. I see another one here with 3xy and 6xy. I add those two, I get plus 3xy. And then I resist the temptation to add 5y squared and 11y. Typically, math problems are designed so that they end up working out really nice in the end. But the truth is that sometimes those terms aren't going to add. So they both have a space in our final answer, 5y squared minus 11y. Now, this is a technically correct answer, but given the circumstances of a particular problem, you may want to arrange the terms slightly different. Maybe you want all of the square terms at the front of your answer, or maybe you just want to leave it the way it is. That's all depending on need and context, depending on how those variables are going to be used and what would be your quote-unquote next step. Maybe there's a factoring that needs to be done, and there's a better way to arrange them. So you have options unless it's clear in the directions which way you're supposed to write your answer. All right, moving down to subtraction, we're going to engage in a similar practice for the first parentheses, just multiplying everybody by 1. So we're left with the same polynomial. But in the second parentheses, everybody's going to get multiplied by negative 1. So negative 1 is going to get multiplied by all 3 of those terms. That turns our negative 11a into positive 11a, our 8b cubed to negative 8b cubed, and our 5ab to minus 5ab. And then again, the hope is that you can start combining. 14ab minus 5ab. Careful, as you always have with combining like terms, to take the sign in front of the term with the number, or with the variable part, excuse me. 9ab, negative 7b cubed minus 8b cubed, negative 15b cubed, and then 11a, and 11a is 22a. I will tell you this is a tremendous candidate for being rearranged because we typically like to have our most dominant power be first. We really weren't worried about that here because we had a few dominant powers, so it's that power of 2, so it's a little bit trickier to do it there. But here we have a clear contender for the highest power, so a good rearrangement into standard form is probably a good idea. So again, adding polynomials, subtracting polynomials, very similar skill set to what you've been doing since you first learned how to combine like terms. Just keeping in mind that we're not combining variables just because we see the same variable. I'm not worried about this b and this b or that a and that a. I need the entire variable part to stay the same, and then I have that extra consideration for subtraction, forcing sign changes on each one of those. So as long as you're careful with those steps, you should have no problem engaging those old skills and applying them to this situation.